Hello my dear students, welcome to my channel. In the last class, we have discussed the solution of a exact differential equation. In this class, we have discussed to find out the solution of a differential equation with the help of integrating factor, right? So first of all, know what is integrating factor. Then after discussed the methods, what are the methods to find out the solution of a differential equation with the help of integrating factor. So look at the given differential equation here. The differential equation is this one, m of xy dx plus n of xy dy. Okay, this is the differential equation. First of all, know what is integrating factor. Remember one thing: if this is not a exact differential equation, because all the differential equations are not exact, you have to know that if del f by del y is equal to del n by del x, then the differential equation is called exact. But if the given differential equation is not exact, that means if del f by del y is unequal to del n by del x, then the factor which multiplied in the left side of the differential equation and it becomes a exact differential equation, then it is called an integrating factor. Okay, remember one thing: there are infinite number of integrating factors for a given differential equation. Don't think that there is a single or there is a particular integrating factor for a given differential equation. You can find out integrating factor for a given differential more than one. So that means there are infinite number of integrating factor for a differential equation. So I have to give only four theorems or four methods to find out integrating factors. Okay, so let's discuss the theorems, and with the help of theorems we'll take some examples and try to understand this theorem, right? And how to find out the integrating factor. I have to first theorem here: if mx plus ny unequal to 1, and we have to consider this equation m of xy dx plus n of xy dy is equal to 0. This is the equation 1. This is the first equation, and this equation is homogeneous. First of all, you have to check the given equation is homogeneous. Then after that, 1 by mx plus ny is an integrating factor of the given equation 1. Then 1 by mx plus ny is the integrating factor. Okay, so first of all, look at the problem. First of all, you have to check the given differential equation is homogeneous or not. Then after, you have to check the given differential equation is exact or not. After that, if the given differential equation is not exact, then you have to just find out the integrating factor and multiplying the given equation, and then check the given differential equation is exact or not. Then you have to find out the solution. Okay, so look at here. Here the degree is 3, degrees 3, degrees 3, degree 3. Okay, the given differential equation is homogeneous. Okay, so take it equation 1 here. So the given differential equation is homogeneous, right? No doubt it is a homogeneous differential equation. Homogeneous. Okay, so no doubt, because here degree is 3, degrees 3, degrees 3, and degree is also 3. So the given differential equation is homogeneous, no doubt. So now m of xy is what? X square y minus 2xy square. N of xy is what? 3x square y minus x cube. So now del m by del y, you have to check the exactness of the given differential equation. So this is 3x square xy minus 6xy. Okay, sorry, actually this one is x square, and del n by del x is what? This is 6xy minus 3x square. Okay, so now since del m by del y unequal to del n by del x, so equation 1 is not exact. So equation 1 is not exact. Now integrating factor is what? 1 by mx plus ny. So integrating factor 1 by mx plus ny, so is what? Mx x cube y minus 2x square y square plus 3x square y square minus x cube y. So you get that this one cancel out, and this is 1 by x square, okay, x square y square. So this is the integrating factor. Now multiply the integrating factor in equation 1. So multiplying the integrating factor in equation 1, we get, what do you get? We get, look at here, multiply integrating 1 by x square y square, so x square is cancelled out, y is cancelled, so 1 by y minus 2 by x, okay, this is dx, plus x square y, 3 by y minus x by y square dy is equal to 0. So this is the given differential equation. Now you have to check the exactness of the given differential equation. So look at here, you have to take it equation 2. So here m dash of xy is what? 1 by y minus 2 by x, and n dash of xy is what? 3 by y by x by y square. Okay. Now just find out del m dash by del y. This is minus 1 by y square, and del m dash by del x. This is minus this is minus 1 by y square. Since del m dash by del y is equal to del m dash by del x, so equation 2 is exact. Okay, so equation 2 is exact, right? Now you have to find out the solution. So the solution is, the required solution is, already you have to talk in the last class. Okay, so integration y treated here, y treated constant 2 by x dx. Okay, and we have to take those terms do not contain x. So here it contains x, so that's why you could take 3 by y dy is equal to x. Remember one thing, here y here in m of xy, y treated as constant, and in that case those terms do not contain x. Okay, so that's why you have to take this term. Okay, if you have to not understand how to find solution, check the last class, check the exact differential equation, it should be clear to you. Okay, so now the solution is x by y minus 2 ln x plus 3 ln y is equal to ln, take c, constant c, so that means x by y plus ln y cube by x square is equal to c. So this is the required solution. Okay, so this is the required solution. Now we have to take some more theorems and to understand how to find out the integrating factors. Students, look at the theorem 2. So it is another method to find out the integrating factor of a given differential equation. So look at here, if mx minus ny and equation 1 has the form f1 of xy y dx and f2 of xy x dy equal to 0, then 1 by mx minus ny is the integrating factor. Okay, so simple, it is a simple form, that means it is form of y dx and x dy, right? So now let's take an example here. So look at it, here y dx and x dy is there, so this is actually in the form, and first of all you have to check the given differential equation is not exact actually. So solution, you can check it roughly that the given differential equation is not exact, so I have to check roughly here. So the given differential equation is not exact, right? So I have to check it here. So now m of xy is what? M of xy is x square y plus xy plus 1 whole into x y dx, and n of xy is what? N of xy is x square y square, sorry, this is x square y square minus xy plus 1 whole into x. Okay, so this is n of xy, this is m of xy. Now integrating factor is what? 1 by mx minus ny. So this one is 1 by x cube y cube x square y square plus xy, and minus x cube y cube plus x square y square and plus minus xy. Okay, so this becomes 1 by 2 x square y square. right? So multiplying this into the given differential equation here. So multiplying the integrating factor in equation 1, okay, in equation 1 we get, what you have to get? You get 1 by 2 of x square y square. So this is 1 plus this is 1 by xy, this is 1 by x square y square, okay, into y dx, plus this is 1 minus 1 by xy plus 1 whole into x dy equal to 0. So now again I have to take 1 by 2 this side, multiply. This is a constant term, so it does not affect the given differential equation. So that's why I multiply. If this is a function, then I can multiply here. Okay. So now it becomes y plus 1 by x plus 1 by x square y into dx plus this is x minus 1 by y plus this is this is 1 by x square y square, so this is 1 by x y square into dy equal to 0. So now here now I have to check this one. M dash of xy is what? Y plus 1 by x plus 1 by x square y, exactness, and m dash of xy is what? X minus 1 by y plus 1 by xy square. So del m dash by del y is what? Del m dash by del y is what? 1 minus 1 by x square y square. Similarly, del n dash by del y del x is what? 1 minus 1 by x square y square. So since del m dash by del y is equal to del n dash by del x, so equation 1 is exact. So equation 2 is exact. So the solution is simple. The solution is integration. Here y theta is constant and those term independent of x. 1 by x square y dx plus, you have to take those term independent. There is a x term, so there is no x, so minus 1 by y, and there is x term, so dy is equal to 0. So now here y theta is constant, so this is xy plus ln x, and this is minus 1 by xy, and this is minus ln y is equal to c. Okay, so this was xy minus 1 by xy plus ln x by y is equal to c. So this is the required solution of the given differential equation. I hope you have to understand this concept. Now let us go to the another method to find out the integrating factor of a given differential equation. Look at the two theorems. These are two important theorems. Actually, we have in maximum case we have to use these two theorems to find out the integrating factor. I have to try in every case. Before two theorems that I have discussed, theorem 1 and 2, sometimes they are used actually, but these two used maximum in each and every cases. When you have to find out the integrating factor, you have to use actually these two methods. These are very, very important to all of you. Okay, so let's understand these two theorems. Look at here. If you have to find out del m by del y minus del n by del x divided by n equal to function of x alone, it should be function of f of x. Then a function of x alone, then integrating factor is e to the power f of x dx is an integrating factor. If you have to divide m and it is a function of f of y, a function of y alone, then it is integrating factor is e to the power minus f of y dy. Listen very carefully. If you have to divide n and it is a function of x alone, then the integrating factor is e to the power f of x dx. If you have to divide m and it is a function of y, then integrating factor is this one. Okay, so let's take an example here. Let's look at the solution. So here m of xy is what? Now this is m of xy, 3x square y4 plus 2xy. Okay, n of xy is what? Obviously this one is 2x cube y cube minus x square. Then so del m by del x is what? So del m by del y, sorry, del m by del y. So this is 12 x square y cube plus 2x. Del n by del x is what? 6x square y cube minus 2x. Since del m by del y is unequal to del n by del x, equation 1 is not exact. Equation 1 is not exact. So now we have to find out integrating factor. Look at very carefully. Del m by del y, del m by del y minus del m by del x is what? First of all, don't divide m and n. First of all, subtract this one and think carefully. Then after that, you have to divide m or n depending on you. Okay. So now this is 12 x square y cube minus plus 2x minus this is 6 x square y cube plus 2x. Okay. So this is actually 6x square y cube plus 4x. So take common, put the common here. 2x you can take common. So this is 3x square 3xy cube plus 2. Okay. There is no term, I think. Okay, here you have to take, if you have to take common x, then it becomes 3x xy common, take common xy, 3x y cube plus 2. Look at it. So we have to just divide m, right? We have to just divide m. M once xy 3x y cube plus 2 xy 3x y cube plus 2. This is 3x y cube plus 2 into xy. So this will cancel out. So we get 2 by y. So the integrating factor is this one. So this one is the integrating factor. Okay. So this one is the integrating. Sorry. This is the function, right? This is the function. Now I have to find the integrating factor. So integrating factor is what? So integrating factor is e to the power minus 2 by y dy. So that means e to the power 2 ln y minus. So this is 1 by y square. Okay. So now we have to multiply the 1 by y square in the given differential equation and it becomes exact. Then after that we have to find out the solution. So let us multiply the integrating factor in equation 1. Multiplying integrating factor in equation 1, we get, what do you get? 1 by x square and 3x square y square 2x by y, okay, dx plus 2x cube y minus x square by y square. 0, right? The solution is okay, 3x square y square plus 2xy, here y theta is constant and those terms independent of x. So there is no terms independent of x, so you have to take 0. dy is equal to c. So what do you get? So you get 3x cube by 3y square plus 2x square by 2y plus 0 equal to c. So what do you get? So you get 3 cancel out, x cube y square plus x square by y is equal to c. So I have to get x cube y cube plus x square is equal to cy. So this is the required solution of the given differential equation. So let's take another example. Look at the problem. He solved the equation x square plus y dx minus 2xy dy equal to 0. So similarly, you have to find out that m of xy is what? M of xy is x square plus y square and n of xy is what? This is minus 2xy. So I have to find out del m by del y. Del m by del y is what? 2y and del m by del x is what? Minus 2y. So since del m by del y is unequal to del m by del x, so equation 1 is not exact, right? Is not exact. So now I have to find out the del m by del y minus del n by del x. Okay, we don't know where to divide m or n. So this is 2y, this is plus 2y, this is actually 4y. So look at it. Here m of xy is x square plus y square, so we cannot divide, but n of xy is minus 2xy. We can divide this one. So divide by n. So divide by n, that is minus 2xy. So this is minus 2xy. So you get y is cancel out. So 2 by minus 2 by x, right? So integrating factor is what? So integrating factor is e to the power minus 2 by x dx. So that means e to the power minus 2 ln x. So that is x to the power minus 2. Okay. So multiplying integrating factor, multiplying the integrating factor in equation 1, what do we get? We get x square y square. So this is 1 plus y square by x square dx minus 2 by x, 2y by x dy equal to 0. Now the solution is, so we have to take y as constant. So integration here 1 plus y square x to the power minus 2 dx, and those term independent of x, so there is a x term, so you cannot take this term. So integration 0 dy is equal to c, right? So this one is actually, this is 1 x plus y square into x to the power minus 1 by minus 1 plus equal to c. So that means x plus minus y square by x equal to c. So this is x square minus y square equal to cx. Okay. So this is the required solution of the given differential equation. I hope you have to understand all the concept today I have to say. If you have a doubt, then ask in the comment box or join in our WhatsApp group following the discussion link. So thank you to all of you. See you in next class.